My name is Abby Kinchy, and today I'm going to speak with you about community-engaged environmental research. Throughout this talk, I am going to pose several questions which are meant for you to consider in relation to your own work. I'm going to use examples from my research, as well as several other case studies. But the idea here is for you to reflect and hopefully reach some new insights about how you want to proceed with citizen science in your own unique situation. So, who am I to speak on this subject? Well, I am a sociologist working in the field of science and technology studies. Public participation in environmental science has interested me for a long time, and I've experienced it in multiple ways. I have studied citizen science projects from a sociological perspective, trying to understand how citizen science and other kinds of participation relate to broader political processes. So along these lines, I wrote the book Science by the People with my co-author, Aya Kimura, another sociologist working in this area. I've also been a volunteer in a watershed monitoring project. And most recently, I'm leading a community science project that focuses on the problem of lead-contaminated soils. So before I go any further, I want to tell you a little bit more about this recent project. You probably know that lead exposure is a serious health threat, especially to children, but really to everyone at all levels of exposure. And unfortunately, it persists in the United States and around the world. Now, certainly you've heard about lead in the drinking water supply, if you've been paying any attention at all to what's going on in Flint, Michigan, and in other cities in the United States. You've probably also been warned about peeling lead paint, perhaps in your older home or in your infrastructure in your neighborhood. What you might not know is that contaminated soil is also a source of lead exposure. Urban soils often contain lead because of legacy pollution from leaded gasoline, industrial activities, peeling lead paint, of course, demolitions of buildings, and other kinds of activities like mining, smelting, and so forth. I like to refer to this as an attritional catastrophe because, of course, the implications for child health are really dire, but the buildup of lead in the environment over time has been a process of slow attrition. And this phrase comes from the environmental writer Rob Nixon. For most city residents, though, it's hard to find out about this kind of pollution. And I wanted to share this quote here from two experts working in this field. They point out that although we do monitor air and water for potential contaminants, there is no systematic program to map urban soil geochemistry and thus to identify and eliminate hotspots from this persistent and toxic pollutant. Indeed, we typically resort to analyzing maps of children's blood lead levels to find these particular pockets of high lead exposure. In other words, authorities wait until children are exposed so that we can find the source of the pollutant. So if you want to find out about lead in your soil before your child gets exposed, which seems like a good idea to me, professional soil testing can actually be costly. It can be confusing to access. A lot of people don't know that it exists. There aren't any mass market DIY testing kits for lead in soil. You just can't run down to Home Depot and get a lead test, at least not for soil. And while there are several government agencies that are responsible for protecting the environment and public health, as you all know, soil lead really hasn't been a policy priority. So most people won't find out about lead contamination until they're faced with lead poisoning in their child's blood test results. So my research team is developing a method of testing soil that engages participants directly in the process of sampling and analyzing the soil and strategizing about how to prevent exposures. And the inspiration for this project came from a team of researchers in Chile. The project is called Nuestros Suelos, Our Soils, and it's led by a sociologist, a colleague of mine in STS. And the focus of the work is really on contamination caused by Chile's extensive mining industry. and the real scarcity of environmental testing of the soil for contaminants from mining. So we are partnered with Nuestros Suelos to try to develop a version of this project in the United States that would focus on city neighborhood soils as well. So the postdoc who's working on this project, it's an NSF-sponsored project, and I was able to bring a postdoc as well as some other collaborators. The postdoc is a chemical engineer by training, and he's been collaborating with others on our team to develop do-it-yourself test kits for lead, for arsenic, and for copper. Copper is especially important in the Chilean context, but anywhere where mining has taken place, as well as lead and arsenic. So we plan to make the instructions for these kits freely available. These will be available to assemble if you can obtain the materials to do so. And we have a community partner in this project, the Sanctuary for Independent Media, an organization that's located in North Troy, New York, which is where I'm located. The Sanctuary has just initiated a new nature lab project. They're building a community lab in this North Troy neighborhood, and it's dedicated to community science for environmental justice. We're really excited to be the first project in that space and to really get to work there in late spring and summer this year. But I said community science for environmental justice, and I want to pause for a second and reflect on that phrase. What exactly does it mean to do community science for environmental justice? For my team, there are 3 important questions that guide our decision making. The first one of these questions is, how can this project help to expand participation in political decision making? Now, we know that in environmental governance, scientific evidence is treated with greater authority than other kinds of claims. And this tends to exclude people without access to scientific knowledge. Having environmental data, of course, doesn't guarantee that you will be heard. So we're trying to think carefully about how to connect the data that we collect with effective advocacy. Since we're working with an organization that has decades of experience making activist media, we think we're going to be able to amplify the voices of community scientists through this project. So here's just a couple of examples of the kind of outreach that we've been engaging in by doing short spots on the community radio station that's based at the sanctuary and doing some outreach at other public events. And I just wanted to highlight the water justice program that's already taking place at the sanctuary. The second question that we're asking ourselves is, how can this project produce knowledge from vantage points that are commonly left out of science? An advantage of citizen science or community science over the science of the regular variety is that it's open to people who have been excluded from professional science careers. This is especially important when mainstream science is not meeting the needs of marginalized social groups, or even misrepresenting their experiences. So this summer, we're going to recruit 15 soil fellows, soil justice fellows, who will include youth, parents of small children, and urban gardeners, all rooted in the North Troy neighborhood where the sanctuary and nature lab are located. Now, this is an impoverished and politically marginalized community. And we want to make sure that these soil justice fellows are the ones who are making key decisions about the questions to ask and the ways to interpret, contextualize, and present the results. So this is one of the questions that we are working really hard on as we develop this project. This image here is back cover of the comic book that we've created with some student artists to help do outreach in the neighborhood. So the third question that we are asking ourselves as a team is, how can this project challenge environmental injustice? We know that environmental problems disproportionately affect social groups that are already oppressed and disadvantaged, and that environmental goods like recreational space and natural resources are unequally shared as well. So to challenge environmental injustice, we realized we needed to look beyond questions about just where the lead is We also have to examine inequality in access to resources for dealing with it and for preventing exposures. I did want to share with you this map, which shows the elevated levels of blood lead among children in our community. The workshops that we're planning will encourage participants to explore and document social dimensions of lead exposure, such as unscrupulous landlords, the history of redlining, and regulatory neglect of urban neighborhoods. As a sociologist, I have to say I'm pretty excited to think about soil lead testing as support for participatory social research. So this is a really interesting challenge for us, and I think a really good opportunity. But unfortunately, because of the pandemic, some of our work has been a bit delayed. We considered how we might conduct community soil workshops virtually. And we decided that this would actually really contradict our commitment to two ideas. First, we're really hoping to develop relationships of care for urban soils, which really requires hands-on observation. And second, we're really interested in building a sense of solidarity, working against the highly individualist approach to lead exposure prevention that has predominated in this country. So because we are really committed to working toward those two goals, we're waiting until we can actually all meet in person, of course, safely, probably masked and socially distanced. So today I can't share experiences from the field, but I'm going to reflect on some of the challenges beyond the pandemic that make this kind of work a little more complex than ordinary academic research. And to do this, I'm going to draw on other case studies that I have written about in Science by the People with Aya Kimura. In our work together, Aya and I have learned that there are actually many dilemmas for those who are trying to use citizen science to advance social and environmental justice. I'm going to present 3 of these dilemmas, again in the form of questions, and reflect on how I'm trying to navigate these dilemmas myself. And I hope that this may be useful to you as well. So, first question. How can you be inclusive when not everyone has the same capacity to volunteer? I'm going to approach this question with an example from the case of fracking. The process of extracting natural gas from hard-to-reach shale formations poses a wide variety of risks to air, water, and soil. Conservation organizations across Pennsylvania and upstate New York, which is the Marcellus Shale gas development region, have trained volunteers to track water quality changes over time. They use devices like this conductivity meter, as well as pH testing kits and other simple tests that can be used by volunteers. As in most of the citizen science projects that we studied, volunteerism is really crucial to this effort. But unfortunately, I found that relying on volunteers to monitor the environment can lead to unequal access to knowledge. In a study that I conducted in 2012, I found that volunteer groups were, in fact, monitoring many watersheds in Pennsylvania, but several watersheds in the heart of gas drilling areas lacked volunteer monitoring efforts. So if you have a look at this map that we created as part of this research project, the outlined areas are watersheds. And when they are shaded in, it means we identified locations where volunteers were tracking water quality. Where there's no shading, that means there were no volunteers monitoring those particular watersheds. So what's notable is the circled area in red, which is an area of the state that has a very large number of gas wells. It's one of the most intensively drilled parts of the state of Pennsylvania. And generally, this part of the state is economically disadvantaged. It's pretty distant from any universities or urban centers, which might explain why volunteer monitoring was lacking there. But the point is that citizen science really can't fill gaps left by weak regulatory programs if communities don't have equal capacity to do citizen science. And our data suggests that all communities don't have the same capacity to monitor their watersheds. They don't have the organizational resources. They might not have the populations that are interested and able to do that kind of work. So this example really highlights a recurring dilemma that we found in our studies of citizen science projects. Frequently, citizen science is framed as volunteering. It's volunteering to help professional scientists, volunteering to share data, volunteering to help your community. But volunteerism has pretty complex implications. Volunteering today is often related to ideologies of small government, market-based problem solving, and the rollback of regulations, social programs, and research funding. I found that some of the volunteers doing water monitoring work that I interviewed had an understanding of these implications. They sensed that their work was vital to the public interest, but several volunteers said that they thought this kind of work should really be done by the state. They were volunteering to fill a gap, but it didn't really seem fair. So we've been thinking about this a lot in our soil research project. And as a result, we're not calling for volunteers. Instead, as I mentioned, we're recruiting soil justice fellows, and we're paying them for the hours that they spend on the community soil study. We're also hiring a participant coordinator, someone who's known and trusted in the neighborhood, to be a liaison with the fellows and their extended community. These are short-term positions, unfortunately, but I hope that we may be able to continue to raise funds for this kind of work. And more ambitiously, we really need to start figuring out how to ensure that all people are protected from lead exposure, not just a handful of fellows. So we're asking, can citizen science help us to work toward that much broader system-level goal? This brings us to our next question, which is, how can you advocate for social change when you're also trying to build a reputation for scientific credibility? Now, in many of the cases that Aya and I studied in writing our book, industry groups publicly ridiculed professional scientists and citizen scientists who collected environmental data. Their accusation was always some variation on the argument that if you have a political opinion, your scientific claims lack credibility. Understandably, this kind of negative attention and even harassment makes many scientists wary of stepping into hot political issues. But for a different perspective on this problem, I want to talk about a case that I studied in Mexico. In the early 2000s, activists in Mexico carried out what we would now call citizen science, though at the time that term wasn't really used. The topic of the project was genetically engineered corn. Mexico is the place where corn was first domesticated. It has an incredible variety of both domesticated corn and wild relatives. And this is one reason why environmentalists and traditional farmers have strongly opposed the introduction of genetically engineered corn. Small-scale and indigenous farmers have also opposed engineered corn, or GE corn, GMO corn sometimes called, because it represents the industrialization of the food system, which threatens their livelihoods and their culture. So in the year 2000, engineered corn was not approved for cultivation in Mexico, but researchers discovered that samples of corn growing there contained genetically engineered material. So how did this happen? Farmers and environmentalists who were concerned about protecting corn and corn biodiversity pointed a finger at imports of genetically engineered corn that were coming to Mexico from the United States. These concerned observers called for more studies. Now, from farmers' perspectives, particularly small-scale and indigenous corn producers, there was a need for specific local knowledge about what was growing in their fields, their particular fields. And from environmental activist perspectives, it was important to build a coalition of people who could advocate for more protective policies. So these two broad groups came together to conduct a participatory study to detect engineered varieties of corn growing in Mexican cornfields. An organizing effort began, and it took place across dozens of rural communities, and it was supported by multimedia outreach, visiting many communities over time. Indigenous and peasant farmers collected samples of corn from their fields, and these were analyzed in a commercial lab. The results were troubling. There were signs of engineered corn growing in 9 different states of Mexico, all without the intention of the farmers. How did the people in this growing coalition use the knowledge they gained from this research project? We might expect they would try to get the results peer-reviewed or validated by regulatory scientists, but instead they focused their energies on directly protecting corn. This effort had 2 prongs. They put pressure on their government to strengthen the rules on corn that was imported from the United States, and they started teaching each other how to maintain genetically diverse corn crops. Now, throughout this time, there were many experts who tried to discredit the evidence that genetically engineered corn had infiltrated the Mexican seed supply. It was an international scandal. Throughout this time period, scientists who expressed concerns about genetically modified, genetically engineered corn in Mexico faced accusations that their science was tainted by politics. But those farmers and activists who had studied it themselves stood by their knowledge, and I think this offers a valuable lesson. Citizen science can give people confidence in what they know, even when authorities are dismissive or want to cover up problems. But if we're going to think about citizen science as a way to strengthen environmental justice activism and create inclusive policy processes, we have to address the norm of political neutrality in science. It is important to resist simplistic arguments against, quote-unquote, politicizing science, and instead ask things like, who is this science for? And what value judgments does it entail? Pursuing these questions is important work for the citizen science community, and we're going to need the support of our universities, funders, science journalists, and others to really push back on the idea that standing up for justice is somehow contradictory to good science. So for my soil team, this dilemma emerges in a few ways, since we're committed to using community science to support political action. One concern is that do-it-yourself tests could be seen as less reliable than the standard laboratory tests that are used in soil research. And we don't want to give people tools that won't be taken seriously when they inevitably face political pushback. We have subjected the tests to rigorous laboratory validation, and we aim to publish the results of that validation process. At the same time, we don't want to focus all of our energy on the scientific analysis and drain our energy for political action. Part of our process of working with community members will be to develop a plan before any testing for taking action, whatever arises, whatever we find in the soil. Participants might decide, for instance, that they want to pursue further testing with a certified laboratory before publicizing their own results. Or they might want to focus on different dimensions of the issue, such as their rights as tenants. We need to be comfortable with not knowing exactly how this is going to go. In the Mexican corn case, we saw that some communities chose to focus on local seed conservation rather than continuing to try to fight for policy change. This brings up questions of scale and the third and final question I want to raise today. How can you connect with people where they live while addressing the broader scale of environmental problems? And for this question, I want to talk about another example from our book, the aftermath of the Fukushima nuclear disaster in Japan. On March 11th, 2011, a massive earthquake and tsunami hit the northeastern part of Japan. Several nuclear reactors lost electricity, and 3 reactors partially collapsed. The government declared an evacuation zone near the reactors and tested food for radioactive contamination. But many people felt the need for more information and better protections. In many communities, volunteers built laboratory testing capabilities to help consumers, particularly mothers, to check food radiation levels. This did not only help them to avoid contaminated food, it also allowed them to resist accusations that they were being irrational or too fearful. Such accusations were widespread in Japan after the disaster and played on cultural stereotypes of overly protective moms. In another project, an organization called SafeCast developed a mobile radiation sensor so that people could monitor the environment and share the data. This work was important, for example, for demonstrating that radioactivity was not limited to the no-go zone that was marked off by the government. The Japanese government as well has promoted some kinds of radiation sensing. Authorities argued that personal radiation devices, using devices like these, allows individual exposure levels to decrease, even if you live in contaminated areas. So today, in some parts of Japan, there are people living in areas that could be considered highly dangerous and uninhabitable due to high levels of radiation if measured in the aggregate from the sky. But by changing the measurement scale to the individual body, the government maintains that it's possible to avoid exposure and stay safe. So people are wearing these monitoring devices and tracking how much radiation exposure they get each day and taking personal actions to avoid higher levels of exposure. The good part of this is it allows people to remain in their communities. They don't have to evacuate. But it also allows the government and the nuclear industry to pass safety responsibilities off to the general public. It's now your job to monitor and reduce exposures. Frequently there are really good reasons to localize and customize environmental monitoring. Monitoring at the individual scale produces data that's really rich in detail. It can align with the individual needs of particular people and social groups. But in this case, hyperlocal monitoring can normalize pollution, making it simply a personal risk to be avoided. So, thinking about our soil project, we actually worry that individualized soil testing for lead might produce this same kind of thinking. So this is the third dilemma that we're grappling with. We know, of course, that environmental problems and their causes are not generally contained in a single nation, region, or community. Even when pollution is localized, the chain of responsibility and causality can transcend boundaries, requiring knowledge and actions at multiple levels. So there are several implications of this for citizen science, and it's important to make a careful set of decisions about the scale of collecting and combining data. It's really not easy to sort out the problem of scale in the case of soil lead. Lead is in our neighborhoods because of a lead industry that operated on a national scale and because of combustion of leaded gasoline everywhere in our country. So what's the right scale for addressing this massive challenge? We are trying to work against the impulse to individualize this problem, letting individual households sort it out for themselves. And we know that the problem is much bigger than our North Troy neighborhood. The best that we can say at this point is that we're going to try to keep these scalar tensions in focus and avoid naturalizing the choice to address lead at the household scale. I'm nearing the end of my time, and I'm just going to conclude by reiterating the questions that I've raised for you today. Whether you are an experienced practitioner of participatory science or you're just thinking of getting into it, I really believe that actively grappling with these questions, along with your collaborators, can increase the impact and the social value of your work. There's really no one-size-fits-all model for grappling with these questions or designing a project. You really do have to go through the process of figuring these things out together. So just to reiterate the questions that I posed today, you can ask yourself, how can this project help to expand participation in political decision-making? How can this project produce knowledge from vantage points that are commonly left out of science? How can this project challenge environmental injustice or other forms of distributional injustice? How can this project be inclusive when not everyone has the same capacity to volunteer? How can my collaborators and I advocate for social change when we're also trying to build a reputation for scientific credibility? And how can this project connect with people where they live while addressing the broader scale of the environmental problems involved? Like I said, there's really no one-size-fits-all model for justice-oriented citizen science. I can't tell you how to answer these questions in the right way for your community, but if we share a concern for social justice, we can begin by taking these questions seriously. So thank you so much for your time. I want to acknowledge several people and supporters. My team, the Our Soil, Nuestros Suelos team, the Sanctuary for Independent Media, the National Science Foundation, Aya Kimura, who collaborated with me in many of these case studies, and of course, all of you for taking the time to listen and to think about the questions I've posed to you today. Thank you so much.